Hi, this is Dr. Prakash, Assistant Professor, Associate Dean Student Welfare, Department of Civil Engineering, SR University, Varagal. So today we are continuing with an problem on your errors in chain and shape. The question is this one, which is shown here, right? So during a geospatial mapping exercise for a proposed field road alignment, students measure a centerline distance using a 20-meter tape. So here you can clearly see the distance length of a tape is 20 meter and it's a steel tape. They have clearly given. So it is standardized at 82 degree Fahrenheit. Okay. So 82 degree Fahrenheit is your temperature of standard temperature. Meanwhile, the field during the measurement is 59.7 degrees Celsius. You can see the standard temperature is 82 degree Fahrenheit and the field during measurement is 59.7 degree Fahrenheit. So there is a reduction in the standard temperature. So the taped length obtained from alignment was 623.45 meters. So that's the total length which is measured. Then because the terrain was highly undulating, the line had to be measured along the several sloping segments. So what they are telling, there is a undulation. So different sloping segments are there. So accordingly, they are going to measure the distance. So the observed slope of 2 degree 15 minutes, so which is your theta 1 over 100 meter, and next is theta 2, which is 4 degree 18 minutes or 120 meters, and that is theta 3, which is 1 degree 20 minutes or 15 meters, so it is keep on continuing. So 180 meter 3 degree 10 minutes or 200 meter, and 6 degree 10 minutes over 66.4 meter, right? So what you have to find is students are required to compute the two horizontal length. So they have to calculate the two horizontal length. So these are calculated for the sloping distance. You can see here. So it is calculated in the different segments like this. So each and every values are given here. So theta values are maybe just make it as theta 1, and this may be theta 2, and this may be theta 3. Okay. So accordingly, you have to calculate, right? Uh, by applying both temperature, so you have to use both your temperature correction and the slope correction. So the coefficient of thermal expansion is 62 degree, 62 into 10 power minus 7 per degree Fahrenheit. So you have to calculate the corrected true horizontal length. Okay, so this length is measured using your this length is measured using this is the horizontal sloped distance with the sloped distance with the inclination degree and the inclination sloped distance. So you have to calculate the true horizontal distance by applying your including a temperature correction. So this is your question. So now we'll go into the solution. So first is step one, what you are going to do, you have to calculate temperature correction. Okay. So what you have to do, you have to calculate the elongation or contraction of a steel tape. So that is given in the question with your standardized temperature and the temperature during measurement. So standardized temperature is 82 degree Fahrenheit, which is given in the question, and the field temperature is 59 degree Fahrenheit, which is also given in the question. And the measured distance is 623.45 meter. So the coefficient of thermal expansion, which is your alpha, it is 62 into 10 power minus 7 per degree Fahrenheit, which is already given in the question. So to calculate your formula for your temperature corrections is so alpha into temperature during your measurement minus temperature of standardized temperature into measured length. Okay, right? So here your Tm is which is given there, which is 59 degree Fahrenheit, and your standard temperature is 82 degree Fahrenheit, and your measured length is 623.45 meters. Okay. So now substitute all your values accordingly. You'll get your temperature correction as minus 0.000874 meter. You can see here in previous problem we have seen it is in positive, but here it is negative. So this negative is you indicate that your tape is contracted. Okay. So yeah, because your standard temperature is 82 degree Fahrenheit and your temperature in machine is only 59 degree. So that's a huge reduction in temperature which leads to contraction of your tape. So your temperature correction is minus 0.000874 meter, which means that I said a tape is contracted due to low field temperature. So a tape is contacted due for a roll field temperature. Now we'll go to the calculation of slope. In that we are having different segments. So the slope angle is given in degree and minutes, right? First, what you have to do, you have to convert each of your slope into decimal. So that can be possible. So slope one is 2 degree 15 minutes. So 2 plus 15 divided by 60 is 2.25 degree. Okay, right? It is 4 degree 18 minutes. So 4 plus 18 divided by 60 is 4.3. So slope number 3 is 1 degree 20 minutes. So 1 plus 20 divided by 60 is 1.33 degree. So slope 4 is 7 degree 18 minutes, which is 7 plus 80 divided by 60 is 7.3 degrees. Similarly, slope 5 is 3 degree 10 minutes, which is 3 plus 10 divided by 60 equal to 3.167 degrees. Similarly, your slope 6 is 6 degree 10 minutes, so 6 plus 10 divided by 60 is 6.167 degrees. So you should have a question that 15 by 60. What is this 60 stand for? What is the thing is, we are converting your minutes into degree. Okay, right? So 1 degree is equal to 60 minutes, right? So 60 minutes is equal to 60 seconds. So what you are doing when you are converting this 15 minutes into degree, you just have to divide this 15 divided by 60, you'll get an answer in terms of degrees, which is 0.25. Okay, right? So that is the reason why you are converting your minutes into degree to make it as a whole decimal numbers. Okay, then so next you have to use a tangent of slope angle to calculate a vertical difference in elevation for each segments. Okay, so the formula is H is equal to L into tan theta, right? Here your L is your segment length. So we are having a lot of segments, right? Previously we have seen in the question. So for each and every degree, there's different segments are there. So that length is your segment length, and theta is your slope angle in radians. So convert degree to radians, which is 0 degree is equal to 0 degree into pi by 4, pi divided by 180. So with this formula, you can convert your. So this is your conversion, what we are using to convert this degree into radians. So continue with your sum. Now we have converted your length. Now we are calculating the elevation difference in each segment. So this is need to be calculated to calculate your horizontal distance. For each segment, you have to calculate h using the given length and slope angle. So your length is 100 meter and slope is 2.25 degree. So H1 is 100. The formula is L into tan theta. So L is your 100 into tan theta is 2.25 degree. You'll get an answer of 3.93 meter. Similarly, for 120 meter and 4 degree, 4.3 degree, you'll get an answer of 9.05 meter. And similar to length of 55 meter and the slope of 1.333 degree will give you the answer of 1.28 meter. Then H4 is a fourth segment which has a length of 180 meter and the slope is 7.3 degree. So 180 into 7.3 degree, you'll get an answer of 222.86 meter. Then length is equal to, which is your 200 meter and the slope is 3.167 degree. So the distance what you are getting is 200 into tan 3.167 degree will give an answer of 11.04 meter. Similarly, for your segment 6, your length is 66.4 meter and the slope is 6.167. So the answer after substituting in your formula, which is your L into tan theta, it is equal to 7.14 meter. So next, after calculating your height difference, now you are applying a slope correction for formula for each of the segments. So that is the so each and every segment should be calculated separately, and then you have to calculate the length. Okay. So the formula is C slope is equal to h squared divided by 2 into L. So this is h square what we have calculated earlier. Now we are substituting those formulas in this calculation of slope correction thing. So segment 1 as same, the length is 100 meter and H1 is 3.96 degrees. By substituting here HY is equal to 3.93 degree. sorry, 3.93 whole square divided by 2 into 100, you'll get answer of 0.0772 meter. Then for 120 meter and calculator is 9.05 meter. So after substituting this, you'll get an answer of 0.3401 meter. Then a length of 55 meter and a height of 1.28 meter, you'll get the answer of uh, 0.0149 meter. Next, with a length of 180 meter and a H4 of 22.86 meter. So substituting in this formula, you'll get an answer of 1.453 meter. Similarly, for 200 meter and H is 11.04 meter, you'll get an answer of 0.3047 meter. Okay. For your last segment, your length is 66.4 and height difference is 7.14. So the answer is 0.3847 meter. So continuing to the next one, the total slope correction is you have to add all your horizontal distance. So it is 0.00772 plus 0.3401 plus 0.0149 plus 1.453 plus 0.3047 plus 0.3847. We'll get answer of 2.5746, make it as 2.57 meters. Okay. So that is your calculated slope corrections. Next, with the slope correction, you are going to calculate the true horizontal length by applying temperature correction and the slope correction. So the true or true is equal to length measured plus the correction for temperature and correction for slope, right? So here you can see your temperature is in negative because we have already seen that negative is due to the contraction of your tape. So 623.43 meter is your length, which is 0.000874, which is negative minus plus 2.5746. So this is positive. So you have to make it as positive correction. So after doing all your correction, your answer is 626.02 meter. Okay. So the true horizontal length of alignment is 626.02 meter after applying both of your temperature correction and the slope correction. So this is calculated. So we have calculated how we have seen how to calculate the slope correction with your degree and their varying segment length. Then with your temperature correction, we have calculated the length is 626.02 meters. So this is your calculated corrected horizontal length. So we will continue with the next example. So with your various corrections techniques. So the question is a group of surveyor assigned to establish a control baseline, okay, for a proposed expressway alignment passing through an undulating terrain. So they have given the terrain is not plain, so it is passing through undulated terrain. Okay. The baseline must be measured accurately. Okay. So your task is to measure the baseline accurately as it serves as a reference. For all subsequent triangulation and leveling work, the baseline should be measured accurately. So it's on 30-meter tape. Okay, a 30-meter steel tape, which is standardized at 17 degrees Celsius. So this is your TS and a pull of 107 Newton. So this is your TS. Okay, is used for measurement. However, during the field work, ambient temperature rise to 22 degrees Celsius. So this is your TM, and the key and the tape, and to keep the tape taut on slightly rough ground, you apply a pull of 159 meters. So this is your pull applied, this is your P. Okay. The steel tape has a cross-sectional area of 0.08 centimeters square and a modulus of elasticity of 2.1 into 10 power 5 Newton per mm square. Okay. So this is your modulus of elasticity, which is your capital E. Okay. And coefficient of thermal expansion is 11.2 into 10 power minus 6 per degree Fahrenheit. So this is your alpha. Okay, that's coefficient of thermal expansion. After laying out a tape several times, the total measured distance was 260 meters. So after several times you are measuring, you are laying your tape on the ground, and the measured distance was 260 meter, and the terrain has a slope of 1 in 4. Okay, so the terrain slope is 1 in 4 under these field condition. Okay, So the measured distance slightly differ from the two horizontal length. So under these conditions, there may be changes. So that's the changes you are assigned to find. Okay. As a part of surveyor team, submit a true length required for accurate alignment of the line. Okay. So this is a question. So they have given a length of tape, standardized temperature, measurement temperature, standardized pull, applied pull. Everything is given with your Young's modulus E and the your coefficient of thermal expansion alpha. So with this, we are going to start the calculation. So as I said, your standardized temperature, which is your TSS 17 degree, and the field temperature, which is your TM is 22 degree, and slope of a terrain is 1 in 4. This means the tan inverse is 1 divided by 4, your theta. Okay, right? How they are calculating theta? It is here 1 degree, your opposite by adjacent. So what they are telling is, uh, so this may be a triangle, right? You need to calculate the theta. So theta is required to calculate. So it is 1 in 4. Okay. So for 1 meter rise, there will be 4 meter horizontal distance. So you need to calculate theta, right? So tan theta is equal to opposite by adjacent. So that's your question. That's your formula. Okay. So from this you can calculate theta. Theta is equal to this tan will go opposite side. So tan inverse of opposite by adjacent. Okay. Right. So your opposite side here you can see this is your opposite side, which is your 1 divided by 4. So that is the theta. Tan inverse is tan inverse of 1 divided by 4. You will get the answer in terms of theta. So that is your inclination angle. Okay. So pull in field, which is your P, and the standard pull, which is your PS. Okay. So the cross sectional area is 0.08 centimeter square, which is equal to, because everything is in meters, so you are converting this 0.08 centimeter square to meter square. So centimeter to meter is 10 power minus 2. So centimeter square is 10 power minus 2 into 10 power minus 2, you'll get 10 power minus 4. Okay. So 0.08 into 10 power minus 4 meters square. So this conversion, you should be cautious on these conversions, because if there is a mistake, obviously the entire answer will go wrong. Okay. So molars of velocity is E is equal to 2.1 into 10 power 5 Newton per mm square. So it is converting this mm square into meter square. So mm square to meter square, mm to meter is 10 power minus 3. Okay. Mm square to meter square is 10 power minus 6. When this 10 power minus 6 go to the numerator, so 10 power minus 6 to plus 6, there is already 10 power 5. So which is equal to 2.1 into 10 power 11 Newton per meter square. So this conversion you should do very well in advance before starting your problem to calculate. Okay. Then coefficient of thermal expansion is alpha, which is equal to 11.2 into 10 power minus 6 per degree Celsius, right? Okay. So gravity of slope we have calculated, which is theta is equal to tan inverse of 1 divided by 4. Okay. So going into your problem, so usually as we are starting with your problem with the temperature correction, okay. So temperature, as I said, it changed the tape length due to different temperature between standardized and field temperature. So the formula is Tc equal to alpha into Tm minus Ts into Lm. So here your alpha is equal to coefficient of thermal expansion. Tm is your field temperature, which we have seen earlier. Standard temperature is given in the question, and measure length is also given in the question. So substituting all the values here, your temperature correction will get an answer of 0.01456 meter. You can see T is equal to 11.2 is here coefficient of thermal expansion, that is 10 power minus 6 here, into 22 minus 17 will get a 5, into your measure length is 260. Okay, so it is 0.01456 meter. You can see the temperature correction is positive, which means the tape is elongated by this amount due to higher field temperature. Okay, so if it is positive, it is an elongation. Your tape is elongating due to changes in the temperature. Okay, so continuing to your next slide. So tension correction. Okay, so the tension correction, it's account for elongation and contraction of your tape due to difference between your applied and standard tension, because there may be a standard tension, but due to you have applied your load, it will elongate due to your applied load, because this is made of steel, right? So when your tension is max more than the permissible strength, okay, right, it will go to plastic stage from the elastic stage. So C tension, the formula is already known, P minus PS into Lm divided by A into E. Here your P is your applied pull, which is 159 Newton. Your standard pull is 107 Newton. Okay. Measure length, it is given in the question, which is 260 meter. So area of cross section is 0.08 10 power minus 4 meter square, which we have already converted from centimeter square to meter square. Okay. So molar velocity, which is 2.1 into 10 power 11 Newton per meter square, which we have converted from Newton per mm square to Newton per meter square. Okay. So substituting all this value, which is 159 minus 107, which is your P minus PS into measure length is 260 divided by your area is 0.08 into 10 power minus 4 into 2.1 into 10 power 11. Okay. By calculating this, we'll get an answer of 0.000848 meters. So that is your uh, tension correction. So this tension correction is positive. It means that your pull which you have applied is higher than the standardized pull. Okay, right? So it is here 0.000848 meters. Now we are going for a slope correction, right? Because they have said it's an undulated ground and there is a slope. So slope is 1 in 4, which we have calculated in terms of degrees. Okay. So slope correction account for the difference between the measured slope and the distance and the true horizontal distance. So formula for slope correction which we have known it is h squared divided by 2 into L m. Okay. So this is your vertical height. H is your vertical height calculated from the slope angle and the length. And LM is a measured length which is given in the question, which is 260 meters. Giving the slope is 1 in 4. The vertical height for each segment of measured length can be calculated as H is equal to LM divided by 4. Because your calculator length is 1 divided by 4, so H is equal to, so 1 LM into 1 divided by, which is LM divided by 4. Okay. So by substituting the measured length, H is equal to 260 divided by 4, you'll get a height of 65 meters. Now apply this 65 meters in your slope correction. So which is 65 square divided by 2 into 260. Okay. So your C slope is 8.12 meters. Okay. So the slope correction is always negative, which is minus 8.12 meter. It means that horizontal length is shorter due to inclination. So your horizontal length, what you have calculated, it should be shorter because we have the sloping distance is 260, which is calculated on the inclined ground. Okay. So when you are calculating this on your horizontal ground, right? So it will take it will take some corrections. So that is, this horizontal distance will be minimal when compared towards your hypotenuse. So your adjacent side will be obviously less when compared towards your hypotenuse. That's your sloping distance. So now we are going to calculate the true horizontal length, right? So now what we have done, we have calculated correction for temperature, which is your T uh, TC plus correction for tension, which is your CT plus correction for slope. Okay, right. So here your correction for slope will be always negative because the horizontal distance will be always your horizontal distance will be always less than your sloping distance. So with this condition, the formula to calculate the true length is your corrector length plus temperature correction, which is already in positive, plus tension correction, which is also already in positive, and your slope correction we already usually take it as in negative. Okay, by applying all this formula, 260 plus 0.01456 plus 0.008048 minus 812. Your length 2 is 260 plus 0.0153 minus 813. So we are adding both the things. We'll get this answer. So your calculated true length is 251.8954 meters. Okay. You can clearly see the sloping distance is 260. Okay. And the calculated horizontal distance is only 251.895. So which indicate that your 260 is more when compared towards your 251.895. Okay, right? So this shows that your horizontal distance will be always negative. I mean less than your sloping distance, right? So we'll have one more example also, right? You are seeing your layout of new airport, right? And runway extension on reclaimed marshland, where the accuracy in baseline measure is critical for aligning the future payment with the control grid. Okay. For this work, you are using a 30-meter tape. Similar, you are using a same 30-meter tape here and standardized in a laboratory at 20 degrees Celsius, which is your TS, and under a pull of 95 Newton, which is your PS, is employed during a field measurement. However, the ambient temperature rises 35 degrees Celsius. So, which is your PM. To keep your tape elevated above the soft or uneven ground, you are suspending it into 5 equal spans. Okay, per tape length. For each and every tape length, you have 5 equal spans, you are distributing or suspending. While your team applies a pull of 135 Newton to reduce the sag. Okay, so yeah, this is your P, right? So that is your PS and this is your P to ensure stability. A tape has followed a characteristic cross-section area of same 8 mm square and H modulus E is equal to 2.15 10 power 5 meter per mm square. And coefficient of thermal expansion is 10.2 into 10 power minus 6 per degree centigrade. Okay. So the unit weight of steel is 78 kilonewton per meter cube. Okay. So this is your question. So these are the given data as we seen earlier. TH is equal to 20 degrees Celsius. CM is equal to 35 degrees Celsius. Your LM is equal to 30 meters. Your P is equal to 135 meters. Your P S is equal to 95 Newton. And H is equal to 8 mm square at 2.15, which we have already seen. And alpha is equal to 10 power 2 into 10 power minus 6 per degree centigrade. Okay. So 78 kilometer per meter is 78 into 10 power 3 Newton per mm square. And it is suspended into 5 equal span for a single tape length. So tape length is 30 meters. So first step, correction for temperature correction. The temperature correction account for elongation and contraction as we seen. Your TC is alpha into Tm minus Ts into Lm. So TC is equal to 10 power 2 into 10 power minus 6 into 35 minus 20 into 30. This is your measured length, right? So your temperature correction is 0.00456 meter. So this is a positive correction which indicate your tape elongate. So elongation has happened because your field measurement is higher when compared to a standard measurement. So this shows that the tape is elongated during your measurement. So next one is tension correction, which we have done. So tension correction account for elongation or contraction of tape due to difference between your applied load. So which is your P, which is given in the question, and PS and LM, A and P. So P is your pull, which is 135, standardized pull is 95, measured length is 30 meter. So cross sectional area we have already converted that 8 into 10 power minus 6 meter square, and the elastic is 2.15 10 power 11 Newton per meter square. So applying this here, you'll get an answer of 0.0006988 meters. So this is positive, which indicate your pull is higher than the standardized pull. Okay, so that's why your tape is stretched, increase your applied tension. So next one is correction for sag. Okay, so the formula to calculate sag is C sag is equal to W L square divided by 80. Right. So W is unit weight of tape, which is 78 into 10 power 3 Newton per meter cube. LM is measured length, which is 30 meter. Applied tension is 135 Newton. Okay. So we have to convert a unit and a Newton meter to for each span. So 78 into 10 power 3 is unit weight divided by 5 equal span. So divided by 5 is 15.6 into 10 power 3 Newton meters. Now substitute into a sag correction formula. So 15.6 into 10 power 3 into 10 30 square tape length into 8 into 135. You'll get an answer of 13.0 meter. So this sag is correction that it's the additional 30 meter. Okay. So the true length calculations, what you have to do, so L true length is equal to measured length, which is your tape length, temperature correction, C tension and correction for that. As I said, your correction for sag will be always negative as your tape is sagging like this. So this correction, it will give a higher length when compared to your actual length. So this correction, you have to subtract every time. Okay, those things you should be keep it in your mind because your sag correction will be always negative. So it is 30 plus 0.00459 into 0.000698 minus 13 meter. We'll get an answer of 17.0053 meter. Okay. So this is your applying. So after applying all your correction, so your corrector length is 17.0053 meter. Even though we are using 30 meter, the corrector length is 17.0053 meter because your C sag is maximum. Right. So this is all about your beautiful example on your tape corrections and your chain corrections. And, thank you.